Most people learning AI will fail, not because they are not learning, which they are, not because they are not following and doing educational content, but because they are learning AI in the wrong way. Because they misunderstanding how learning actually work in the domain of data science that AI is a part of. AI is not learned like other subjects. Then how is it actually learned? You may have asked yourself this question, and why is learning AI different? First, let us understand how humans usually learn subjects. Broadly, we can cluster learning into 5 major categories. The first is learning through memorization and cramming. Subjects like history, geography, and biology often fall into this category. In these subjects, learning happens by memorizing facts such as historical dates, names of rivers, or different types of cells. Next comes learning through experimentation. Have you ever been confused in your high school chemistry class about the color of a reaction, such as benzene? That confusion often exists because you have not experimented enough. Chemistry in particular is learned best through hands-on experimentation. Observation and repeated trials form the foundation of understanding here. Then comes learning through thinking. Subjects like physics and philosophy belong to this cluster. In these areas, deep thinking and reasoning provide clarity. You do not simply memorize formulas or statements, you think through concepts to truly understand them. After that, we have learning through practice. Mathematics and real-world skills such as martial arts, cooking, and many others fall into this category. Here, improvement comes from repetition. The more you practice, the better you become. However, there is another important cluster of learning, and AI belongs to this category. Treating AI like any of the other subjects is the first mistake people often make. AI is not learned in the same way. Learning AI through pure memorization, experimentation alone, or only practice does not fully work. It would be like learning history through experiments or chemistry purely through cramming. While it is possible to some extent, it is not effective. AI requires a fundamentally different learning approach. So what is that approach? Before understanding the approach, we must first understand the subject itself. Let me start by asking you 2 questions. First question, do you know whether AI is a subject under data science or computer science? You probably guessed it correctly. It falls under data science. Pretty simple, almost like cake. Now comes the second question, and this is where most people get confused. Why is AI a part of data science and not computer science? This is a difficult question, and believe me, this is exactly where the real answer lies. So why do you think AI belongs to data science? If your assumption is that AI needs data, that alone is not sufficient. Computer science also heavily depends on data. Storage systems, websites, applications, and databases all rely on data. You might argue that AI uses heavy data, but that still does not explain why an entirely new domain exists just because it works with more data. So why data science? The reason is that data science operates in an area that traditional computer science does not fully cover, and that missing piece is statistics. Data science is not just about writing code or building systems. At its core, it is about understanding uncertainty, probability, patterns, and distributions. These ideas come directly from statistics, not from traditional core computer science. And this is exactly why artificial intelligence naturally belongs within data science. Data science relies heavily on statistics. Concepts such as hypothesis testing, sampling, modeling, and inference are fundamental pillars of the field. Without them, data science simply cannot exist. Now, where does AI fit into all of this? AI is built on 2 fundamental statistical ideas: probability and feature engineering. In fact, almost the entire foundation of modern AI is rooted in these 2 concepts. At its simplest level, AI's job is prediction. If you have ever used ChatGPT and wondered how it works, the answer can be summed up in one word: prediction. Large language models take your input and predict the next word, one token at a time, until a full response is formed. In self-driving cars, AI predicts what a human driver would do in a given situation. In recommendation systems, AI predicts what you're most likely to watch, buy, or click next. Even the most complex AI systems are, at their core, prediction engines. This is why AI aligns more closely with data science than with pure computer science. Computer science focuses on building systems and algorithms. Data science focuses on extracting meaning, uncertainty, and predictions from data. But prediction alone is not enough. AI also depends heavily on another major statistical concept: feature engineering. You may have noticed that large language models are trained on massive datasets, yet only a few models like ChatGPT or Gemini can generate truly human-like responses. Many companies invest billions of dollars, train on similar data, and still fail to cross performance benchmarks. Sometimes, even your own model refuses to improve no matter how much data you feed into it. Why does this happen? The answer is feature engineering. Feature engineering is the statistical process of understanding what we are training on and why it matters. It involves techniques such as hypothesis testing, z-tests, chi-square tests, and monitoring feature importance to determine which inputs actually influence the outcome. In simple terms, your output is only as good as your input. To build a successful AI model, the data must be carefully analysed, selected, and engineered. This is where statistics truly shines. Feature engineering is the practical application of statistical thinking to shape data into meaningful signals. AI is not magic. It is the reflection of the data we provide. Just like the saying goes, what you consume is what your body becomes. In the same way, what you feed into an AI model determines what it can become. Thus, the true path to mastering AI runs through statistics. Anyone can ask ChatGPT to generate an AI model, but only a real AI engineer can use statistical analysis to build the best possible model. This brings us to the final and most important element of learning how to think statistically. You do not simply use a feature, you understand its statistical significance and its contribution to prediction. You do not just train a model, you analyze how it behaves, why it succeeds, where it fails, and how to optimize it correctly to build truly effective AI systems. This is the difference between using a model and mastering it. At its core, AI is deeply rooted in statistics, and this is the real reason the AI revolution cannot replace jobs in the field of data science. It is not because AI will rebel against its creators, but because statistical reasoning itself cannot be automated by a purely predictive system. Predictive models excel at replacing repetitive tasks, but statistical analysis demands human judgment, intuition, hypothesis formulation, and critical thinking. These abilities come from understanding, not from prediction alone. That is why data science remains irreplaceable in the age of AI. And if you are an aspiring AI engineer, you now know where your journey truly begins. If you have experience but have not deeply applied statistics yet, this is the moment to start. The AI revolution is not coming, it is already here. All the best for your next AI model. Hi, my name is Ayusman Samasi, and you are watching AusDev. I make AI documentaries and also do practice sessions on AI learning too, like my last 100 days of deep learning practice, and we will have our 100 days of Hugging Face practice and 50 days of Gen AI practice course too very soon. So subscribe my channel to get notifications, and I will see you next time. Thank you for watching.